Hello, pre-calculus and honors pre-calculus students. Welcome to Unit 3, Topic 1, Lesson 2. We're going to evaluate all 6 trig functions in a coordinate plane. So we're going to start with our warm-up, review the check for understanding from yesterday. You'll have an opportunity to correct the check for understanding from yesterday, or if you feel good about your check for understanding from yesterday, you can work on your homework. We're going to go over a problem like number 1 from the homework. We'll do a quick time to climb, brain break, problem like number 2 in the homework, and then time to work on the rest of the homework if time permits. And if you've already turned in your homework, you can begin working on your formative. We'll close out with a summary and exit poll. Just a reminder that your homework and your week 1 formative are due on the 10th, so next Wednesday. These are the materials. Obviously, if you're watching this pre-recorded, you know, have your screen structured however you would like, but we're using Zoom and Nearpod today. If you'd like to take the time to go to the modules, resources to get a slide deck, print out a slide deck capture sheet, you can, or you can take paper, pencil, notebook paper if you wish to take notes. Okay, so for our warm-up, we're going to find the missing side of all the triangles that are here. I'm not sure why it says all positive values because they're not all positive. So this is an example here. So in quadrant 1, we have a 3, 4, 5 right triangle. Our x coordinate of the terminal side is 3, the y coordinate is 4, and then the hypotenuse is 5. So these are all going to be integer answers. I don't have any decimals. I don't have any irrational numbers on here. They should all come out to be integers. So find the missing triangle length in quadrant 2, quadrant 3, and quadrant 4. Okay, so go ahead and pause the video, give that a try. I'm assuming you've paused the video and looked at it. So here is the review of it. So I'm going to erase all positive values. I'm not sure why that says that. So quadrant 2 is the upper left quadrant. So x is negative left, right? So -5 is your x value. 12 is still your y, and then 13 is your radius. Quadrant 3, everything's negative except tangent. So your x value is negative, your y value is negative, and then your hypotenuse is always positive. Quadrant 4, positive 55, negative 48, and positive 73. Right, so these are all triangles in the coordinate plane. These are just some Pythagorean triples that are helpful for the SAT. So you might want to memorize them, or at least get them sort of embedded in your brain a little bit, because it is helpful to know these Pythagorean triples. And if you don't know your Pythagorean triples, at least think about your perfect squares up to 20 if you can. All right, so I want to review the check for understanding from yesterday. So this check for understanding said if the sine of theta is -8/10 and the terminal side of theta lies in the 4th quadrant, what are the exact values of the other 5 trig functions of theta? So these would be all the correct answers. This is a 6, 8, 10 triangle. So over here is the Pythagorean theorem worked out. And then, when we take the square root of 36, we have to say, well, is it positive or -6? It has to be positive because we are in the 4th quadrant, right? So the 1st and 4th quadrant are the right side of the y-axis. So x is going to be positive in quadrant 1 and quadrant 4, just like we talked about in the warm-up. So now that we know all 3 sides of the triangle that captures that terminal side, we can do all of the trig ratios. So cosine of theta, adjacent over hypotenuse, 6/10, tangent, -8 over +6, secant, hypotenuse over adjacent, cosecant, hypotenuse over opposite, and then cotangent, adjacent over opposite. So some people went ahead and reduced the fraction, which is great, especially if you're looking at like a multiple choice question, and this is one of the options. It is good to know that 10 divided by 6 is equivalent to 5 divided by 3, right? They have a common factor of 2. Some common mistakes from the exit card were assigning the wrong numbers to the wrong side. So some people said, well, 8 and 10 are the side lengths of the triangle. You have to really think about the fact that sine is opposite over hypotenuse. So O over H. So this number 10 is going to be the H. It's going to be the long side, the radius. So that was a common mistake, people doing 10 squared plus 8 squared equals r squared, and then they would get a decimal. So just be mindful of that. And then another thing, and I know this is really common, remember that sine goes with cosecant. Those are the reciprocal pair. And then secant and cosine go together. Those are the reciprocal pair. And sometimes if you forget, I give you a little mnemonic device as a hint. The C matches up to an S. So sine, cosecant, SC, and then cosine, secant, CS. I don't actually know why they chose those names. It almost seems intentionally confusing, but if you're the type of person where mnemonic devices help you, like PEMDAS is a mnemonic device, right? Just remember that. So what I mean by that mistake is that people would write that the secant is negative 10 over 8, right? When really negative 10 over 8 is the cosecant, because cosecant is the reciprocal of sine, okay? And then the last thing is just the positive, negative signs in the different quadrants. So speaking of mnemonic devices, some people, like all students, take calculus in the quadrant. So quadrant 1, everything's positive. Quadrant 2, sine is positive. Quadrant 3, tangent is positive. And then quadrant 4, cosine is positive. And then everything else would be negative. So some people like that. I personally don't like that. I just remember that this is a coordinate plane, right? In this quadrant, in quadrant 1, X and Y are both positive. In quadrant 2, you're going to the left. So Y is positive and X is negative, right? So I think about it just in terms of when you're graphing a point, right? What does that point, is that point going to be positive or negative? So however, whatever way is beneficial to you to remember it. Okay, so because the terminal side of this angle lies in the 4th quadrant, 6, our X value is going to be positive, and negative 8, our Y value is going to be negative. And that was kind of the point of the warm-up. All right, so you now have an opportunity to correct your check for understanding. If you're watching this on a recording and you would like to do that and you didn't have a chance to do it in class, email me so we can get it done. All right, so now I want to do a problem like problem 1 from the homework. So drawing an angle in standard position, because there were different levels of mastery on that. So when you sketch an angle in standard position, you want to draw your ray in whatever the quadrant is, and then draw a little, sort of a little arrow extending from the x-axis where you are at 0 degrees all the way to your angle. Right? And then you can just write, you know, the angle, or you can write theta. So that is how you sketch an angle in standard position. So 210 would be a little past 180, 30 degrees past 180. So it would go right here. And then negative 160 degrees, negative, you go clockwise, and then your arrow terminates right before negative 180. So 20 degrees south of 180. Okay. And then one thing that I did not teach you is that if you have an angle that terminates on an axis, it actually is not in any quadrant. It's called a quadrantal angle. So plus or minus 0, 90, 180, 270, 360, those are all quadrantal angles. So if you answered between quadrant 3 and quadrant 4, that's right, but you don't really have to say that it's in a quadrant. It's a quadrantal angle, it's on an axis. All right, time to climb. If you're watching this on a recording, I'm sorry you missed it. Brain break, you go at your own pace. Black History Month spotlight on Mae Jemison. Take a look at her, really inspiring. First Black woman to travel to space. Overcame low expectations from her teachers. All right. So I want to review, I'm assuming since you're watching this on a recording, you took whatever brain break you needed. And I want to review this problem from part 2 of the homework. So here we have this lovely little angle with a terminal point that, or a terminal ray that passes through negative 1, 2. So here we go. And we're supposed to find all the trig ratios, right? So here we're not missing an X or a Y, we're missing an R, because our X is negative 1 and our Y is 2. So we need to use the Pythagorean theorem to find the hypotenuse, the radius. So -1 parentheses squared plus 2 squared equals r squared, right? So we solved that. A lot of people were getting 3, I think because you just took -1 squared and kept it negative. Remember, when you square something, when you square any real number, it will be positive. So you should end up with +1 plus r, and then we have +1 plus 4 equals r squared, excuse me, and then we have 5 equals r squared, and then we have square root of 5 equals r, and it has to be positive. It's, we always say plus or minus, but our radius is positive, right? We don't really ever mess with that. So +√5 is our r. So now that we have all 3 sides of this triangle, we can say, okay, our sine is 2 over √5. Our cosecant is √5 over 2. Our cosine is -1 over √5. Our secant is √5 over -1. Tangent is +2 because it's 2 over -1. And then cotangent is -1/2. All right. So if you're ready, you would go ahead now and start on the formative. If you'd rather take that time to work on the homework, that's great. And then just to summarize and close, so today we solidified our understanding of evaluating trig functions when one side of a triangle is missing. We learned to draw an angle in standard position, and then we identified which quadrant various angle measures were given, where they were in. So I hope that helped. There's a little bit of an exit poll to see where you're at, if you're ready to move on, what you need to do for next time. And that is it. That's the lesson. So thank you so much for watching, and email me if you have any questions, and I'll see you next time.